Let's talk about the rules of probability. So starting with the fact that probabilities got to be between 0 and 1 inclusive. That means it includes 0, that means it doesn't happen, and includes 1, which means it's certain to happen. In percentages, that's 0% to 100%. You can't be over 100%, and you can't have a negative probability. This next rule, the probability of an event not occurring, is 1 minus the probability of an event occurring. That's rule number 2 here on the list. So if there is a 80% chance you will show up to class on time, then there's a 100 minus 80, 20% chance you will not show up to class on time. And that is called the complement rule. Not a compliment like you have a very nice shirt, but a compliment meaning the opposite here. So the complement rule is the probability of it not occurring is 1 minus the probability of it occurring. And if you don't see the word not, sometimes they'll use, like, for instance, probability of A, C for complement as a superscript in the notation. This next one, the probability of A or B occurring, this one is what's called the general addition rule overall. So I'm going to put a little arrow here to kind of right off to the side here. This is called the general addition rule. It's the probability of A occurring plus probability of B occurring minus what they have in common. So if I asked you, like, for a deck of cards, what's the probability of getting like a king or a heart overall? Well, then that would be how many kings are in a deck, and it turns out there's 4 out of 52. Woo! How many hearts? There's 13 out of 52. But you double counted the king of hearts. So you got to subtract what is in common overall. And that's the setup for the general addition rule. Now, if the events here are disjoint, which means they have nothing in common, then the probability of A or B is going to be the probability of A just plus the probability of B because they have nothing in common. Like if I ask what's the probability of getting a king or a jack, for instance, there's 4 out of 52 kings, there's 4 out of 52 jacks, and there's no such thing as a king jack in a deck of cards. That's why you don't include that last one. So disjoint is on a single pole, and they have nothing in common, then it's just the probability of A plus the probability of B. Now, this next rule, the probability of A and B, is actually used for what's called independent events. And this is on separate trials, like flipping a coin and flipping a coin again. Okay, so for an example of that one, if I ask find the probability of flipping a coin 2 times and getting heads both times, well, the first time would be 1 out of 2 chance. The next time would be 1 out of 2 chance. You certainly don't add them because it can't be 100%. It can't be 1. You would multiply to get a 1 out of 4 chance in that case. And the difference between independent and disjoint is independent is multiple trials. Flip and flip and flip again. Versus disjoint is on a single flip or a single pull of a card or a single roll of a dice. If you happen to see the notation again, like for complement rule, you might see this notation. For the word and is going to be the upside down U for intersection, and or is going to be for the union overall. So you might see these notations instead of and versus or. And then lastly, at least one is the 1 minus none case. So let's do some examples here. Given any bag of Skittles, the following probabilities of picking a color are as follows. Red, orange, yellow, green, purple. I made these up. What is the probability of selecting a green Skittle? Well, it's missing. It's got a question mark. So what are we going to do? We're going to know that they all add to 1. So we're going to do 1 minus the sum of all those other probabilities. 0.10 plus 0.15 plus 0.25 plus 0.30. Add those all together in parentheses. You'll get 0.80. 1 minus 0.80 is 0.20. There's about a 20% chance of pulling a green Skittle here overall. Right there. Boom. What is the probability of not selecting an orange Skittle? Well, if the probability of selecting an orange Skittle is 0.15, 1 minus 0.15 would be 0.85. And essentially, I did what's called the complement rule. I did the probability of orange not occurring. I'm using OR for orange and little c for complement, and that's what it equaled. What is the probability of selecting a red or yellow Skittle? Well, the probability of a red Skittle would be 0.10. The probability of yellow Skittle would be 0.25. Add that together and you get 0.35. And a follow-up question would be, what kind of events is this if you're doing a red or yellow Skittle? And the answer is disjoint. Because I'm just pulling a single Skittle, I want to know if it's red or yellow. What is the probability of selecting 2 red Skittles? Well, the first red Skittle is 0.10, and the next one is 0.10, so you'd be multiplying to get 0.01 or a 1% chance. And again, the assumption here is these events would have to be considered independent for this to occur. And let's talk about at least one, okay? So you get 4 Skittles and at least one is yellow. So the probability of at least one is 1 minus the probability that none are yellow overall. So the probability of being yellow is 0.25. The probability of not being yellow is 0.75, but it's not yellow and not yellow and not yellow and not yellow. And in this case means to multiply, so that'd be to the 4th power. So 1 minus 0.75 to the 4th would be the probability of at least one being yellow. At least one is 1 minus the none case. And this is a pretty standard chart dealing with all those different probabilities. Now, if they just want to take all the, I don't want to say fun out of it, but just do numbers, that's what example 2 is for. You're given the probability of A is 0.3, the probability of B is 0.2, find the probability, or probability of A and B is 0.4. Are these disjoint? Well, the rule to be disjoint would be the probability of A or B is equal to the probability of A plus the probability of B. So let's see. In this case, the probability of A and B is 0.4, 0.3 plus 0.2. That's a hard no. No. They're not disjoint in this case. Now, independent, the probability of A and B is equal to the probability of A times the probability of B. All right, let's test this one. Probability of A and B is 0.4 in this case, apparently. And is that 0.3 times 0.2? And again, the answer is, well, no, that's not going to occur in this case either. So therefore, I would say confidently that these are not disjoint, these are not independent in this case. Not everything is going to be disjoint, not everything is going to be independent either. And there's several examples dealing with the rules, here they are one more time, of probability.